Hello students, today we are going to discuss the important topic in liquid state, that is surface tension. In the last class already discussed the important characteristic, that is vapor pressure of liquid. We know matters are divided into three parts: solid, liquid and gas. They mainly differ from one another on basis of their intermolecular force, intermolecular space. But if you see for a particular matter, the nature of liquid, the characteristic of liquid molecules, or maybe any matter, the molecules of that particular matter inside the matter and at the surface, the nature differ from one another. Let us see the liquid molecule. Suppose liquid kept in this container containing liquid. Here, this is the liquid, up to this liquid occupies liquid, and these are the surface molecule. You can say these are the surface molecule, and under this another liquid layer also present, like this. These are the liquid layer. So first layer, you can say first layer, second layer and third layer. Let it be like this. Let it be. So suppose this is the first layer, is the surface layer. This is the surface of the liquid. And if you see the intermolecular force faced by the molecule, suppose this is the molecule, suppose this is the center molecule, it is faced by this is the center molecules. Attraction, it is attracted by molecule in all directions, because both sides molecules are available. So due to this intermolecular force, this center molecule attracted by the molecules in four directions, so that the center molecule remains in static. You can say it is the balanced force. If you apply the law of physics, the all type of force, upward, downward, and left side and right side, both are cancel each other. That's why molecule can be remain in static, in state, that is in equilibrium, that means without disturbing, because it is attracted by all directions. But if you see, consider the molecule at the surface, it is only attracted by this molecule and this molecule and this molecule, like this. So only surface molecule, and here also other molecules are there. So surface molecule, if you see the intermolecular force, there is no force above. There is no force above. Above there is no force. Only surface molecule facing downward pole, because the molecules occupying at the below the surface. Below the surface molecules are occupying, which are attracting the surface molecule downward. That's why surface molecule facing a downward pole. It is facing a downward pole, because there is no molecule on the above the surface molecule. So the surface molecule always facing a downward pole. That's why they are always in a tension. They are facing downward pole. facing downward pull. So this surface molecule facing a downward pull. Due to this downward movement, due to this backward pull, the surface molecule remain in tension. Remain in the tension. They are facing downward pull. That's why they remain in tension. This type of nature of the surface molecule, that molecule of liquid, is called surface tension. Due to this surface tension, the surface molecule facing a downward pull. So this downward pull means force. This downward pull means is a force. This force is done. This force is due to the molecule under the surface. Under the surface of the molecule. So how this force? How much force? How much force is acting? Force acting tangentially. Force acting tangentially for unit length. For unit length is called surface tension. Is called surface tension. Surface tension is generally symbol is gamma. So due to this backward pull, surface molecule facing a tension and remains in a tension, and the membrane, the surface molecule, suppose consider as a straight membrane. This surface molecule remain in just like a straight membrane. It will be looks like the straight membrane like this. Due to backward pull. Due to backward pull, the membrane, the surface molecule, considered as an imaginary line, it will be straight like this. Suppose it is very simple example you can take. If you take one cloth and put some weight at the middle of the cloth, then cloth will be what? It will be pulled downward. If you see, it will not be like this, it will be like this due to the weight. Similarly here, due to backward pull, the surface molecule is pulling downward. That is called your surface tension, and this surface tension is measured in terms of force acting tangentially for unit length, for unit imaginary length is called surface tension. So surface tension, that is gamma, is equal to force per unit length. What is the unit of surface tension? That is Newton per meter or dyne per centimeter. Dyne per centimeter or Newton per meter. This is the unit of surface tension. But you see, due to this surface tension, as the surface molecule is pulling downward, if you see the shape, it is become a curve shape. The surface molecule become curve shape. Due to the curve shape, if you see, suppose this is, so all molecule will pulling downward, inward. So what happens? This surface molecule, the liquid, acquires a spherical shape. Spherical shape. Due to this surface tension, due to the force acting on the surface, the molecule acquire a minimum area. Minimum area means spherical shape, so that it balance the surface tension. The interfacial tension will be balanced when it takes the shape, spherical shape. That's why liquid molecule takes a spherical shape. liquid takes a spherical shape always due to surface tension. And to increase the surface area, to increase the surface area per unit, to increase the surface area, to increase the surface area, how much the amount of energy consumed to increase surface area. Due to surface tension, surface area is decreased, because due to surface tension, the surface molecule pulled downward. Due to this, it acquires a curved shape. That means in both sides it becomes spherical shape. So when the surface area decreases, so how much energy is utilized to increase the surface area? To increase the surface area, the amount of energy consumed per square centimeter, per square centimeter is called surface tension. This is called also surface tension. So surface tension also can be defined in terms of energy. The amount of energy consumed per square centimeter, what? To increase the surface area per square centimeter is called surface tension. That means already surface area is decreased. How much energy is utilized to increase the surface area per square centimeter? That is called also surface tension. So surface tension gamma can be written as that work done, that means energy per unit area. That means we can add what is the unit of work done? Joule. Joule per centimeter square. Or it can be written as that joule per meter square. This two unit you can write, joule per centimeter square or joule per meter square. So you can, it depends upon the unit. If you are taking a centimeter square area, then it will be joule per centimeter square. If you are taking meter, a joule per meter square. So this is the gamma, that is surface tension, can be expressed in some force per unit length or in terms of energy utilized, consumed to increase the surface area. To increase the surface area of the liquid, that is called joule per centimeter square. That is also called surface tension. So in terms of force per unit length or amount of work done or to increase the surface area per square centimeter, that is called also surface tension. So both are correct in terms of expression. Energy required to increase surface area per square centimeter or how much force acting per unit length, that is also surface tension. So what are the factors affecting surface tension? What are the factors? Factors already know. Surface tension is a force. So first is nature of liquid. Nature of liquid. Nature of liquid already know. Gamma is proportional to intermolecular force. If intermolecular force is more, then surface tension is more. For example, mercury has more surface tension compared to water. Because in case of mercury, the interfacial attraction is more, interatomic attraction is more, that's why surface tension is more. More attraction, more surface tension. So this is nature of liquid. Then temperature. So surface tension inversely proportional to temperature. Because when you increase the temperature, the interfacial tension will be decreased. That means the intermolecular attraction is decreased. That's why surface tension will be less. So more temperature, more low surface tension, less surface tension. Hot water has low surface tension than cold water. Because hot water has higher temperature, the surface tension is less. So that is temperature, nature of liquid. Another thing is, suppose you are solute. When you add solute to the particular solvent, suppose organic solvent, organic solute. Organic means covalent nature. Organic solute decreases the surface tension. Surface tension decrease when you add oil to water. Surface tension will decrease. Another thing, if you add salt to water, in this case increase. So very important. When you add organic solvent, organic solute, that is your kerosene, petrol, any oil to water, surface tension decreases. But when you add salt to water, surface tension increases. So these are very important. Why this? Because oil decreases the interfacial tension. That's why surface tension will decrease. But salt will, due to as it is ionic, so attraction between water molecule will be more. As it is salt is ionic character, then it increases the polarity of water. When salt will be added, then due to this ionic nature, the polarity of salt will be more. That's why it increases surface tension. So these are the important factors related to surface tension. Then we will discuss what are the application. Very important is application. Application part already we discussed, that is first application is raindrops is spherical effect. Raindrop spherical shape. Why raindrops are spherical? Due to surface tension. Already I explained this one. Due to surface tension, the molecules acquire minimum area, that is spherical shape. Needle or blade floats on water. If you keep a plastic needle or you keep a blade on the surface of water without disturbing, then it will float continuously on water. This is due to the surface tension. Difficult to separate the wet glass plate. This is also one application. If wet glass will be wet, if glass plate will be wet, then it is very difficult to separate. This is due to surface tension. Due to surface tension, the water molecule attract the glass plate, both sides, upper glass plate and lower glass plate. In between water molecule remain. Water molecule attract the glass plate due to the what? Surface tension. So difficult to separate wet glass plate. Due to another application is that soap clean the cloth. Mainly soap water clean the cloth, because soap decreases the surface tension of water, so that water molecule can enter into the dirty substance. The cavity of dirty substance water molecule can enter due to the decreasing surface area. That's why it easily clean the cloths, dirty cloths. So soap solution clean the cloth, that is also a application of surface tension. Mercury takes convection and water takes concave shape in capillarity. In capillarity, mercury takes convex shape and water takes concave shape. For example, like this is your mercury and this is your water. This is the mercury shape. Already you have seen the shape of the mercury meniscus in the thermometer, that is upward, convex shape, and water will be downward. So this is due to one important thing, remember, due to surface tension. Here one application is mercury and glass attraction is less than mercury and mercury. Mercury interaction is more, and in case of water and glass, what happens? Water and glass interaction is greater than water and water. Force between similar molecules, that is called cohesive. This force is called cohesive force, and this mercury and glass is called adhesive force. That means mercury and mercury same, that is called cohesive force, and mercury and glass, that is called adhesive force. Cohesive force, in case of mercury, cohesive force is more, but in case of water, adhesive force is more. This is the difference between the mercury and water meniscus in the capillary tube, only due to this. So this is the one application. Then we can think other examples. Another example we can write: water wet the glass, but mercury does not. Already we have seen, if you touch water to glass, then water drops stick to the glass, but mercury does not wet the glass, because mercury attraction is more. That's why what glass cannot, that mercury cannot be stuck, that it will not be stick to the glass. But in case of water and glass, what happens here, water and glass interaction is more compared to water. That's why the water drops stick to the glass. So this is the difference. Water wet the glass, but mercury does not. That's why we are using mercury in the thermometer, because mercury cannot wet the glass. So these are the very important application of surface tension. So in our day-to-day life, we are doing so many activities, but we are unknown about the application of the science. So what is surface tension of liquid? What are the units of surface tension? And what are the expression of surface tension? Surface tension can be expressed in force per unit length. Surface tension can be expressed in what? Amount of energy needed to increase surface area. How much? Per square centimeter or per square meter. That is called also surface tension. This is the unit. And what are the factors affecting surface tension? Very important. Nature will different liquid has different surface tension. If you see, mercury has more surface tension than water. For example, mercury greater than glycerin, greater than water. You will see. And water greater than alcohol. Water also greater than alcohol. Like this. So it depends upon the intermolecular force. If intermolecular force is more, surface tension is more. And another temperature. Temperature breaks the intermolecular force. That's why surface tension is inversely proportional to what? Temperature. Hot water and cold water, or normal water. Hot water has a lower surface tension. You have seen that when you wash your cloth, if you take hot water, the cleaning will be better. The cleaning will be faster, because when you use hot water, the surface tension again decreases. Already that I will detail. The soap water or your detergent water clean the cloths because it decreases surface area of water. But when you take hot water, again your surface tension will be more. Surface tension will be less. Hot water has a lower surface tension. If surface tension of the particular liquid will be less, then the cloth can be easily clean. That is one application of surface tension. So you practice more regarding the application, factors, and the definition and unit of surface tension of liquid. Okay, thank you all.